Nuclear binding energy is the energy that would be required to disassemble the nucleus of an atom into its component parts. These component parts are neutrons and protons, which are collectively called nucleons. The binding energy of nuclei is due to the attractive forces that hold these nucleons together, and this is usually a positive number. Since most nuclei would require the expenditure of energy to separate them into individual protons and neutrons, the mass of an atomic nucleus is usually less than the sum of the individual masses of the constituent protons and neutrons, and this missing mass is known as the mass defect, and represents the energy that was released when the nucleus was formed. The term nuclear binding energy may also refer to the energy balance in processes in which the nucleus splits into fragments composed of more than one nucleon. If new binding energy is available when light nuclei fuse, or when heavy nuclei split, either process can result in release of this binding energy. This energy may be made available as nuclear energy and can be used to produce electricity, as in or in a nuclear weapon. When a large nucleus splits into pieces, excess energy is emitted as photons and as the kinetic energy of a number of different ejected particles. The nuclear binding energies and forces are on the order of 1,000,000 times greater than the electron binding energies of light atoms like hydrogen. The mass defect of a nucleus represents the mass of the energy of binding of the nucleus, and is the difference between the mass of a nucleus and the sum of the masses of the nucleons of which it is composed.